Hello everyone, this will be the Level 2 Physics 2023 full walkthrough. Let's get right into it. The stationary player accelerates from the home plate to first base. The player takes 6.61 seconds to get to first base and arrives moving at 5.45 seconds. Show that the average acceleration is 0.825 meters per second. So average acceleration is equal to change in velocity over change in time. So change in velocity is initially the player is not moving, so it was at 0 seconds to 5.45. So the change in velocity is 5.45. It took 6.61 seconds, and this is equal to 0.825 meters per second squared. Calculate the maximum displacement between the home plate and first base. So that's just the distance between here to here. Distance is equal to initial velocity plus final velocity over 2 times time. And this is equal to 0 plus 5.45 over 2 times 6.61 seconds, and this is equal to 18.0 meters. Why might this displacement be different from the actual distance traveled by the player? So basically, displacement is the position between the player and home base, but distance traveled considers the total change in displacement. That was slightly worded badly, but it's just that displacement is just the position, but distance traveled is like the total. It's like how long you went back and how long you walked, basically. The softball has a mass of 0.18 kilogram, is thrown at 44.4 meters per second, and is caught and brought to stop at first base. The catcher's arm is relaxed, and the ball and padded glove move backwards a little once the ball collides with the padded glove. The ball takes 0.51 seconds to stop. This results in an impulse. What does the term impulse mean? I think they just want change in momentum and where change in P is equal to force change in time. Let me just check that's the correct formula. Yeah, there it is. So calculate the average force the ball. So basically, if it comes to a stop, that just means the final momentum is 0. So change in momentum was 0.18 kilograms times 0.18 times 44.4 meters per second, which is equal to 0.92 kilograms meters per second. So basically this and yeah, and we have this equation: change in p equals force change in time. Force is equal to change in p over change in time. This is equal to 0.92 over 0.15, which is equal to 15.5 newtons. Yeah. Use physics principles to explain the advantages of catching a ball using a relaxed arm and a padded glove. So basically what you got is I'll bullet point this. Change in momentum is a constant defined by change in p is equal to force change in time. Relaxed arm will give more time. So basically, having a relaxed arm will means there's more like give. There's like more give between the while it catches. So there's like a bit of a dilution of force as you catch it. So yeah, relaxed gives more time slash wrist for the ball as it impacts the glove. Because of the relaxed arm and padded glove. And more time means force gets diluted over time. Meaning the impact while catching the ball is is weaker. And then I guess we can just write change in p equal to force change in times more time going up will result in force going down. Later in the game, a 50 kilogram player moving to the right at a speed v collides with a 60 kilogram player who is moving to the left at 0.4 meters per second. The two players collide and stick together and move to the right at 2 meters per second after the collision. What physical quantity is assumed to be conserved during the collision? This would be a conservation of momentum. Okay. Yeah. Okay, so let's set this, moving this side as positive, and because this is going the opposite direction, this would be negative. So so basically, conservation of momentum says p before is equal to p after. So momentum before is, so previous momentum is the total momentum. So 50. So p. So there's this momentum and this momentum. So that will be 50 times velocity. Take away 60 times 0.4 is equal to p before. This is equal to this is equal to 50 v take away 24, and p after after the collision, the two people stick together and move this way at 2 meters per second. So p after is equal to, so yeah, since they stick together, that is their total mass, which is 110 times 2, which is equal to 220. Okay, yeah, I should probably kilograms meters per second. So p before is equal to p after. So 50v take away 24 is equal to 220. 50v is equal to 244. V is equal to 44 over 50, which is equal to 4.88 meters per second. Technically, they only give us this value, which is one significant figure. So technically, you should round to v is equal to 5 meters per second. But they should accept this answer. So velocity is equal to 5 meters per second. Question 2. A player with a mass of 55 kg moving at a constant speed of 7 meters per second follows a circular path as they round second base. The radius is the circular path is 15 meters. Calculate the centripetal force acting on the player as they round the base. Force centripetal is equal to mass times v squared over r. Let me just okay, yeah. So basically, force centripetal in this context will be 55 times 7 squared over 15 meters. This is equal to 179.66, which if we round to 3 significant figures, which show which all values have do, we get 180 newtons. Technically, this, if we want to be very specific, we can write 1.8 all times 10 squared newtons, but yeah, this 180 newtons should be fine. Add labeled arrows to the diagram below to show the direction of the force, acceleration, and velocity of the player. So in the centripetal force, the force and acceleration is always moving towards the center. So this man is moving towards the center. But the velocity is always tangential to the circles at which the position of the player is at. So this is force and acceleration. but the velocity is moving this way. V. Name the force that supplies the centripetal force acting on the player as they move in a circle. This is just the friction force. Friction force between the foot and the track that keeps them together. I don't know, this is a bit weird. Explain why the player can be moving at constant speed and yet be accelerating at the same time. So, velocity is a vector. Unit, while speed is a scalar. So vector has a direction while speed doesn't. So basically, yeah, velocity is a vector unit. So a vector unit always has a direction and a scale, while a scalar is just a scale. So velocity means you're going in a certain direction. So basically, because of this, a player can move at constant speed, but continuously change directions. But constantly change directions. And hence accelerate his and x is also a vector, and yeah, you can mention centripetal acceleration. The person is moving at constant speed, but changes direction all the time, so accelerates. The player runs onto a slippery, muddy patch while rounding the base. Describe and explain fully using physics principles the effects this slippery mud will have on the player's motion. So there's no friction force supporting the player over the muddy patch. No fiction. So no woods centripetal force acting on the player. So person slip off track and move at a constant speed. Tangential to the circle from where they slipped. So basically, there'll be no friction force supporting the player over the muddy pitch. So the inward centripetal force will be lost. So the inward centripetal force acting on the player will be lost, and the person will slip off the track and move at a constant speed, tangential to the circle. So let's say this man is running, but running around the circle, but there's a muddy patch here where this person slips off, so this person will go this way. Question 3, projectiles. Next batter hits the ball up in the air with an initial velocity of 22 meters per second at an angle of 35 degrees. Show that the vertical component of initial velocity of the ball is 12.6 seconds. So velocity is velocity times sine of theta, which is equal to 22 sine of 35. This is equal to 22 sine of 35. Where's my notes? Oh yeah, there. This is equal to 12.6 meters per second. Calculate the maximum, and yeah, we can verify that this is 12.6 meters per second. Calculate the maximum height reached by the ball above the ground. So basically, considering this vertical component, like this vertical component, considering the vertical component, there's always a downward acceleration acting, and the maximum height is when the projectile motion is around here, where the velocity is 0. So Vf is equal to Vi plus At. We let the vertical acceleration be 12.6 meters. The initial vertical velocity component is 12.6 meters, and at max the velocity is 0 meters per second vertical, since it's not going up or down. 0. And since gravity is acting downwards, and we set the vertical upwards velocity to positive, this means acceleration is negative, so gravity is negative. So 9.8 t is equal to 12.6, which implies time is equal to 1.286. Wait, let me check. 12.6 divided by 9.8, 1. Right. Okay, 1.2857, okay, is 10 divided by 7. Okay, so time is equal to 1.286 seconds. So the time, so the time it takes to reach this maximum height is 1.286 seconds to reach max height. So and then we can use the equation distance is equal to I plus v if over 2 times time. So initial vertical velocity is 12.6 plus, and the final velocity is just vertical velocity is just 0 over 2 times 1.286. Distance is equal to this. This is just equal to 8.10 meters. 8.10 actually, but we need to remember reach above the ground. This is the ground, so we need to add another 1.6 meters off from this total height. So adding another 1.6 is 8.10 plus 1.6. This is equal to 9.70 meters. Actually, 1.6 is two significant figures, so we can just write this. Will be. We can just write two significant figures. Use physics. Add labeled use to explain motion of the. Add labeled errors of appropriate. Okay, so basically, as at A, when there's like this momentum of this force going upwards, but then at max height there's only this, and which we can pick it up into. So basically the initial vertical force is strong enough to overcome the gravity force. So there's here, and there's the sideways velocity. At max height, there's like there'll be gravity and right here. Read my notes. As labeled errors appropriately errors of appropriate length to show the forces on the ball at a maximum height. Okay. Basically there's like no so yeah. So basically gravity, there's always the gravity force, but okay. So there's always this gravity force, and the sideways force is always a constant, since there'll be nothing in the way of that sideways movement. Technically, yeah, but we never consider air friction, and yeah, there's also always this downwards and sideways force, which is going this way, and yeah, this is also going this way. Okay, I'm not too confident with that answer. Okay, describe and explain how the forces acceleration and horizontal and vertical velocities of the ball changes to its flight. Okay, force. Force is always a actually gravity is more of acceleration. Actually, wait, let me just check real quick. Okay, yeah, just checking it. Yeah, okay, yeah. It's downwards gravity force acting. Wait, yeah, okay. Okay, I'll assume that I'll assume E resistance will be is negligible. Force acting on the ball. Downwards gravity force action on the ball. Yeah. It's always a downwards force acting on the ball. And okay, acceleration. The acceleration due gravity vertic is 9.8 meters per second squared downwards. And no, yeah, I don't really like how this is formatted a bit. I don't really like it too much. No, sidewards acceleration. Okay, horizontal velocity. No side. Okay. Not. So sideways is bad. No. Horizontal acceleration. No. Horizontal velocity is a constant as there no shifting the horizontal. Yeah, okay. The horizontal velocity is always a constant because like this, you need a acceleration to change its velocity, but since there's no acceleration sideway horizontally, it will just remain a constant velocity. The velocity will go upwards, reach up max and upwards. Okay, actually upwards to max. Okay, at the point A here, reach max at B. Alright, no, will 0 at max height max height B, and will go down. It's at C. There's always a downwards force action. The ball. Okay, I guess. Would there be a horizontal? Okay, yeah. This. Wait, let me just check. Okay. So basically, okay, this is wrong. Okay, so yeah, there's only gravity. Okay, yeah, there's no horizontal force acting on the ball since the ball constantly moves horizontally at a constant velocity, so constant speed. So there's like no horizontal force acting on the ball. And yeah, the acceleration, there's always the acceleration due to gravity, but there's no horizontal acceleration since it remains constant. I mean, there'll be nothing bothering the horizontal horizontal acceleration. Horizontal velocity, because it remains constant because acceleration is zero, and vertical velocity will go upwards and then reaches at max and reaches zero at max point, then go downwards. I didn't like this one because they gave no diagram. The 110 kilogram coach and a substitute player of mass 74 kilograms sits on a uniform bench. The mass of the bench is 40 kilograms, so I want to draw. I'll draw my own. A person I kind of wanted to see how this looked in the exam, to be honest. On the above diagram, okay, so basically, this man is going downwards. This man is giving a force downwards. This man is also giving a force downwards. And this support bench has a force downwards. Then this support A gives two upwards. These two supports give upward forces. Calculate talks about support A, B, or otherwise. Determine the value of the support forces at A. Okay, from my notes, yeah, okay, I decided to do it the other way. I let A be, okay, you can do either way, but I let A be this. I let this be the origin, and so basically if we just ignore B and only have this, this torque will go this way, so that the support B is supporting anti-clockwise. I mean, so basically, normally if we have nothing, if this B didn't exist, this bench will fall clockwise, but this bench, but this support is helping anti-clockwise. Okay. So, and this bench and this man, anti-clockwise. This bench and this man, this player B is, I mean, not this player will be anti-clockwise, and this coach will be clockwise. Okay. So, torque anti. So you torque clockwise. It's basically this whole length is 1.5 meters. From here to midway is 0.75 meters, and this point A is wait, am I? Wait, let me just check. Okay, yeah. This bench is 0.3. Yeah, this bench is 0.3 meters away. 0.3 meters away from the center of mass, so it's been shifted 0.3 meters. So 0.3 times and torque is equal to force times distance. So yeah, this distance is 0.3 times 40, which times 9.8. So this is the okay. It might be better to write torque of bench plus torque of plate is equal to torque of coach plus torque of support B. Okay, so yeah, so this is torque of bench and torque of player. From point A, the player is 0.42 plus 0.6 meters. So that is 1.02 times the mass is 74 times 9 times 9.8. This is equal to torque of coach. So torque of coach is 0.35 meters away and 110 kilograms. So 0.35 times 110 times. And yeah, the acceleration is, this force is just gravitational force by gravity. And this support B is 0.6 meters away, so plus the force of B times 0.6. If we add this together, this will give 857.304 is equal to 377.3 plus 0.6 force of B. 0.6 force of B is equal to 480,004. So force of B is equal to 800 newtons. I think this was like 799 newtons or something, but yeah. Okay. So, and then yeah, downwards force. So that this downwards force must add to this upward force. So force A plus force B is equal to 40 times 9.8 plus coach is 110 times 9.8 plus player 74 times 9.8. So, and we know that force of B is equal to 800, so force of A plus 800 is equal to 2,197. Wait. Let me just put this in my calculator. 219. Okay, so 2195.2. So if A is equal to 1395.2, okay, yeah, they want three significant figures, so force of A is equal to 1400 newtons. Okay, right, let me just, yep, that's the end of the paper. Let me just check. Yeah, okay, I have the units for everything. Yep, units. Units. Yeah, I got the units. Okay, yeah. Thank you for watching and goodbye.